Okay, number 20 in chapter 3 gives us a picture of two people pulling on a mule and tells us about each of their individual forces and asks you to find what we will call the net force, so the total force on this. Okay, so we don't know for sure that it's going to be right on the y-axis, but it's going to be somewhere in between, so I'm just going to draw it that way for now. And the way we know to add vectors, well, we know two ways, one of which is to do it graphically, which we haven't really examined too much. But I can take this vector here.
I was at the leadership conference.
Yeah, that's fine.
With the background. Oh, sorry.
No, that's fine. Now, apologies for any interruptions. I am currently on duty in Freeman, and it's very weird to them that I'm talking to my computer. But anyway, so we know about each individual force. We know it gives its magnitude. F1 is actually, hang on, 120 newtons, and F2 is just 80 newtons. Okay, and it also gives us each of their angles with respect to the horizontal. So we can add these graphically by taking, for example, one of these and simply shifting it up to somewhere like here. Okay, in which case we now know, so the net vector would point something like that. Now, unless we make really precise measurements of length and angle and all those things when we are drawing this, that's not really a way to get to a specific solution. So, but it does give us a general idea of what our result should look like. So our result should have a very big y component, a reasonably small x component. And we don't know for sure if the x component is going to be positive or negative, but we can assume that the y should be positive. Okay, so how do we do this? Well, as with all two-dimensional problems, we split it up into the x and the y. Okay, so if I find the x component of f1, add it to the x component of f2, I get f net x. And likewise with the y components. Okay, f2y equals f net y. Okay. Now over here I'll write our general equation for the two components. Okay, the x and y component of any vector r. Okay, so in finding the x component for example, f1, okay, when we take the cosine, we will get that leg of the triangle. We take the sine, we'll get the vertical leg. Okay, you get your x and y components. Okay, once we find f net x and f net y, okay, then those are the two legs of a big right triangle. Okay, and if I put them together, okay, what I'm trying to find then is the hypotenuse. And of course I can do that with the Pythagorean theorem. Square root squared plus squared equals the magnitude of f net. Okay, now I can also then, okay, so that gives me the magnitude. I need to find the direction. Okay, so I need to find theta. Well, we saw in class that theta is the inverse tangent of y component divided by x component. So you should have a pretty good idea of where to go with this problem from here. If you're still stuck, you can check the solutions after the homework is turned in. Part B throws in a little bit of a curveball because it asks you what is the force that a third person would have to exert to cancel out the other two. Well, go away. Okay. Well, it would be exactly the same in magnitude as the F net that we find, okay, but it would be exactly opposite in direction. Okay, exactly like that. So the same magnitude, opposite direction. Good luck.